Let's take a look at polar coordinates. Now, used to rectangular coordinates, and this is a way to express a point. So I could express a point this way, 2, 2. And this is our x part, and this is our y part. So I could come over, let me make that a little bigger. So this point right here I could express in this manner. Well, there's another way I could express this. If I look at going from our initial side up to here, that's an angle, like theta. And then this distance right here is r. So the distance from the origin out to the point. So that's another way we could represent that point, and that's polar coordinates. And we represent it as r comma theta. So this distance and then this angle, and that'll also allow us to represent that. Well, these first problems here says match each point in polar coordinates with either A, B, C, or D on the graph. Now, you see how it goes up here? That's a positive pi over 5. And negative pi over 5 would be going the other direction. So it goes clockwise. So right here we'd be sitting here at D. Now this one has something unique about it. See how the negative 8, well, see how the 8 is negative. Well, if it was positive 8, it'd be going in the same direction where the angle is. Since it's negative 8, it flips around to the other side, and our answer is B as in Bill. So number 1 is B. Let me emphasize that again. First thing you do is you go out the angle. And that's negative pi over 5, so that's right down here in this where D is. And then you look at your R. If it's a positive number, you go out in that same direction to where your angle is. If it's a negative, you go in the complete opposite direction, 180 degrees over on the other side. So, here's pi over 5. Let's look what C would be. Okay, so this is pi over 5. One way of representing C is we got pi over 5, and then if I go to R as negative 8, it'll go back over to here. So this I could represent as pi or negative 8 and pi over 5. Now A is just pi over 5 and a positive 8, like that. This will make more sense as we look at the next examples. It's kind of a weird concept for people at first. Number 2 says plot each point given in polar coordinates. Well, that means this is R, and this is theta. Excuse me. First thing we do is we got 135 degrees. Again, this is our initial side. 135 degrees is over to there. Now, since this is a positive 5, that means we'll go out a distance of 5. So this distance right here would be a distance of 5. And this would be our point. So again, we went 135 degrees, and then we went a distance of 5. And since it was positive 5, we went out this way. If it had been a negative 5, we would have went down here to quadrant 4. Let's look at this one. Negative 2 and pi over 4. Same instructions, plot each point given in polar coordinates. Well, this is R, and this is theta. Pi over 4. This right here would be pi over 4. Now we're starting at the origin right here. If it had been a positive 2, we would have went out a distance 2 here. But since it's a negative 2, we go out a distance of 2 over here. So that distance there is 2. And our point would be right here. So again, we used our angle to go out to tell us where do we start at. If it's a positive 2, we go the same direction where that angle is. If it's a negative 2, we go completely the opposite direction, 180 degrees over there. So that would be our answer. Now I'm not putting any tick marks on my axis here, so 5 here, I could put 5 out here. If you don't have any tick marks, and it's kind of vague, all I'm trying to demonstrate here is where is it located at. So we got 4, negative 3 pi over 4. Well, again, this is r, and this is theta. Negative 3 pi over 4. Well, if I start here and I go back that way, negative, you go in this direction, clockwise. Here's pi over 4, 2 pi over 4, that's 3 pi over 4. Now, and it's a positive 4, which means we're going to go out a distance of 4 in the same direction where this angle is. So again, this right here would be a distance of 4. Let's take a look at this one. Negative 2 and negative pi over 4. This is r, and this is theta. Well, negative pi over 4. That'd be that right there. Negative pi over 4. And since r is negative 2, then we're going to go out the complete opposite direction. And we'll go out a distance of 2. So again, we're pretending this distance right here is 2. And that would be our point. Now, if it had been a positive 2, we would have went out in the same direction where the angle is. But since it was negative 2, we went the opposite direction, 180 degrees over there. And let me save this. Polar coordinates. PDF. There we go. And we start a new page. Let's look at our next problem. We got 5 and pi over 4. It says plot each point given in polar coordinates. Let's do that first. This is r and this is theta. So we'll go out pi over 4, which would be right here. And our r is positive, so we're going to go out a distance of 5 in this direction. So that'd be a distance of 5. So that's the first part. Now A says r is greater than 0, and we got negative 2 pi is less than or equal to theta is less than 0. Now this says find other polar coordinates r or theta of the point for which these are true. Now this point doesn't change. It's always got to be right here. We're just going to represent it in different ways. Now this tells us that r is going to be greater than 0. That means r is going to be positive. So we have to keep the 5. We don't have any choice on that. But this says your angle is going to be between negative 2 pi and 0, not including 0. So the angle is going to be negative. Well, a very easy way to get a negative angle is to subtract 2 pi. And this is a mixed number, so I can take negative 2 pi times 4 gives you negative 8 pi, plus pi gives you negative 7 pi over 4. Because remember, I'm right here angle-wise. If I subtract 2 pi, we're going to go all the way around our circle, and we're back to where we were. So we're still at the same point, which is what they're wanting. Now B says r is less than 0, and then it's theta is between 0 and 2 pi, not including 2 pi. Okay, r is less than 0. That says r is negative. So I know without a doubt I have to have negative 5. Well, remember what negative does. Negative means that you go in the opposite direction. So for my angle, I want to be over here. So let me put a smiley face where I want to be. I want to be right here. Because if I went r is negative 5, I would go back the opposite direction, and I would end up at this point. Okay, so my angle has to be between 0 and 2 pi. Well, if I think about this, here's pi over 4. To get to this angle between 0 and 2 pi, I would just add pi. So I have pi over 4 plus pi. And this is a mixed number form, so we have pi times 4 is 4 pi, plus pi gives us 5 pi over 4. Now our r is on negative, and the angle is between 0 and 2 pi. So again, we go 5 pi over 4, which is over to here, and then go negative 5, which goes me back here, which gives me that same point. Let's take a look at the next one. So we got r is greater than 0, and our angle is between 2 pi and 4 pi, not including 4 pi. Okay, r is going to be greater than 0. Well, that means r is positive, so 5. Now, since it's a positive 5, that means we want to be right here. We're currently sitting at pi over 4, but we want the angle to be between 2 pi and 4 pi. Well, that's easy. We'll just add 2 pi. So I'm going to have pi over 4 plus 2 pi. So we have 5 here. 2 pi times 4 is 8 pi, plus pi is 9 pi over 4. So again, r is positive, and our angle is between 2 pi and 4 pi. And if I went 9 pi over 4, that's like 2 1/4 pi. Start here, 2 pi is all the way around. Another quarter pi would be right here, and r is 5 means I put my point right there. So again, these all right here give you the same point. They're just different way of representing it. Let's look at another one of those. Okay, so we're given negative 4 and negative 5 pi over 6. Let's first plot this and see what it looks like. Negative 5 pi over 6. That would be over to here. And scratch my ear. There we go. And then negative 4 means I'd go out a distance of negative 4 in the other direction. And that would be our point. So again, I went negative 5 pi over 6 over to here, and since the r is negative, we'd go back distance to 4 in the opposite direction. So that's the point we're working with. So let's look at what they're asking for. A, r is greater than 0, and theta is between negative 2 pi and 0. So theta is negative, basically. Now I want to end up here. Well, if I started here, that's negative 5 pi over 6. If I subtract another pi, that would give us there, and the angle would be negative. Now r is greater than 0, which means r has to be positive 4, which means we want to end up in this particular quadrant. This is where we want to be. So again, this is negative 5 pi over 6. And if I went another negative pi, I would be right here. Well, this is a mixed number. Negative pi times 6 is negative 6 pi plus negative 5 pi gives us a negative 11 pi over 6. Okay, negative 11 pi over 6. That's just shy of negative 12 pi over 6, which is negative 2 pi. So negative 11 pi over 6, if I looked at it, would go from here all the way over to right here. And since the r is positive 4, we got a distance of 4 in this direction. So that works. Now B. R is less than 0, and theta is between 0 and 2 pi. Not including 2 pi. R is less than 0. That means we want a negative 4. Now, negative 4 means I want to be down here. Because if I'm down there and my r is negative, then it'll flip over and be over on this side, which is where I want to be. So this is where we want our angle to be. Between 0 and 2 pi. Well, if this is negative 5 pi over 6, this little piece right here is pi over 6. And this is pi, so we got pi plus pi over 6. That gives us, what, 7 pi over 6? Now let's see if that works. Start here, 7 pi over 6 would be over to right there, and negative 4 I'd go back in the opposite direction, and I'd end up there. So that works. And C, r is greater than 0, and 2 pi is less than or equal to theta, is less than 4 pi. R is greater than 0. That means we want it to be positive. So we got positive 4. So where we want to end up at is we want to be in this quadrant. Since it's a positive 4, that means we'll just go out in the same direction as the angle. Now this is between 2 pi and 4 pi. Well, if I were to go up here, if this is negative 5 pi over 6, this little piece right here is pi over 6. If I go pi over 6 and then add 2 pi, I'll be back there. So again, this little piece right here is pi over 6, and then I add 2 pi, and it goes all the way around, and I'm back to where I was. So our answer will be 4, and this is a mixed number form. So 2 pi times 6 is 12 pi, plus pi gives us 13 pi over 6. Well, that's 2 and 1/6 pi. So if I start here, 2 pi is all the way around, 1/6 pi, pi over 6 is right there. And then my r is positive, so I'll go out in this direction. Oops, I didn't circle it. And those are our answers. Let me save that, even though I might have room to continue there. Next problems ask us to do some conversion. It says the polar forms given, convert it to rectangular. So let's look at some of our formulas to help us with this. Grab a drink. Okay. Now recall, and I'm going to erase these, but recall from before, we have cosine theta is equal to x over r, and we had sine theta is equal to y over r. We had tangent theta is equal to y over x. We had r squared is equal to x squared plus y squared. The neat part about this section is it just kind of builds upon what we've already been using. Like here, if I multiply both sides by r, I get r cosine theta is equal to x. Now r and theta, that's our polar, and then x is of course our rectangular. So our first formula is x is equal to r cosine theta. Now here I can multiply both sides by r, and we get y is equal to r sine theta. Now along with those, we have cosine theta is equal to x. Well, it should never have to use that. Famous last words. Now we got this one already. Tangent theta is equal to y over x. And r squared is equal to x squared plus y squared. Now we could also drop the squared and put the square root around the other side. Now we don't worry about putting a plus or minus there because r is always positive for purposes of what we're looking at here. Now we know we can put r as negative, but we can treat it as always positive. Let me erase all those now. There we go. So those formulas we're going to be using. And let's take a look at number 8. We got 7, and then pi over 2. It says the polar coordinates are given, find rectangular. So this is r, and this is theta. Well, we got some formulas for that. X is equal to r cosine theta, and y is equal to r sine theta. Well, r is 7, and then cosine of pi over 2, and here r is 7, and sine of pi over 2. Well, I'm up at pi over 2. Cosine is equal to 0, so I got 7 times 0. So x is equal to 0. And sine of pi over 2, I'm over pi over 2, sine is equal to 1. So we got y is equal to 7. So our point would be xy, which would be 0, 7. Now again, to look this up, you can use your unit circle. I brought it up here somewhere. There we go. So cosine pi over 2, remember you go to pi over 2, cosine is your x part, which is 0. That's where we get that. Sine pi over 2. We go to pi over 2, sine is our y part, which is 1, which is where we get that one. And this is our answer. These first ones work out nice because they'll come up with something on the unit circle. But we won't always have that. So here we got negative 3 and 5 pi over 6. And this is our r, and this is theta. Now remember I said over here we treat r as positive. Doesn't mean it won't start out as negative, but we can always write it as positive. That's why we go with this formula. So now our formula says x is equal to r cosine theta, and y is equal to r sine theta. So r is negative 3 cosine of 5 pi over 6, and y is equal to negative 3 sine of 5 pi over 6. Now cosine of 5 pi over 6 is negative square root of 3 over 2. Here a negative negative gives you a positive, so we got 3 square root of 3 over 2. On this one, sine of 5 pi over 6 is 1/2. So we get y is equal to negative 3/2. So our point would be 3 square root of 3 over 2 and negative 3/2. Now again, if I look this up, cosine of 5 pi over 6, here's 5 pi over 6, cosine is our x part, which is negative square root of 3 over 2. Which is where I got that at. Negative negative is positive. Sine 5 pi over 6. Here's 5 pi over 6. Sine is our y, which is 1/2. Which is where I got that. So that's our answer. Number 10. We got negative 2.5 and 133 degrees. This is r and this is theta. Same instructions, write it in rectangular form. Well, obviously, this isn't going to be on our unit circle. So all we can do is use our calculator. Remember our formulas, x is equal to r cosine theta, and y is equal to r sine theta. So I got negative 2.5 cosine of 133 degrees, and y equals negative 2.5 sine of 133 degrees. Doesn't say how many decimal places. I'll take them to 2, I guess. I don't think it says. No, it doesn't. And no calculator up and running. So let me bring it up and get a drink while I'm doing that. I want to make sure I'm in degrees, so I'll press mode. And I am in degrees. If you're not in degrees, down arrow to that line, right arrow, put your flashing cursor on degree and press enter to highlight it, and then do a second mode, exit out. Okay, so our first one, we got negative 2.5 cosine of 133 degrees. And we get 1.70, 1.7. And the y. I'll have negative 2.5 sine of 133. And we get negative 1.83. So our answer will be 1.7 and negative 1.83. If it's not on the unit circle, then the approximation like we're doing there is the best you can do. Now these next problems are asking us to go the other direction. They're giving it to us in rectangular, and they want us to put it into polar. So we got 0, 5. Now, what did I say, rectangular? Yeah, they're giving it to us in rectangular, so this is x and this is y. If we go up to our formulas, we got r for one thing. That's very easy to find, so let's do that first. So going from rectangular coordinates to polar coordinates. This is more than just finding or plugging in two simple formulas. So first step is to find r. So r is going to equal to square root of x squared plus y squared. So r is equal to 0 squared plus 5 squared. 0 squared drops away. 5 squared is 25, and the square root of 25 is 5. Again, we'll always treat r as positive unless there's a specific reason why we need to switch it for these formulas. Now, check if on a unit circle. So check if on the unit circle. And we do that by just kind of working the problem. So you're trying this first. Remember our formulas. We had cosine theta is equal to x over r. And we had sine theta is equal to y over r. Well, we know what x is. X is 0. And r we said was 5, which would give us 0. Y is 5. And r is 5, which would give us 1. So we're looking on a unit circle. Remember, cosine and sine on your unit circle are your x and your y. So this would be 0, 1. So if we go around our unit circle, then at 0, 1, we're going to see theta is equal to pi over 2. 0, 1, pi over 2. And then our answer, since we now know r and theta, it'd be 5 pi over 2. Again, r and theta. Now, if it's not on unicircle, let me go ahead and write these steps down here. If not on unicircle, we want to use tangent theta is equal to y over x, or theta is equal to inverse tangent of y over x. Now you could also think that as arctangent. Those symbols are the same. So that's arctangent of y over x. That's just a little bit too small down there. We put it over here. Or theta is equal to arctangent of y over x. Now we'll see some problems dealing with that, but let me save this. And we'll take a look at our next problem. And I think this one's on a unicircle also. So I got -6, -6. It's given it to us in rectangular and want to change it to polar. Well, this is x and this is y. To change it to polar, remember our first step is to find r. So we got r is equal to the square root of x squared plus y squared, which is -6 squared plus -6 squared, which is 36 plus 36. 36 plus 36 is 72, which is 36 times 2, which is 6 times 6 times 2. With a square root, we're looking for a pair of numbers, so this pair of 6 is going to come out. And we got 6 square root of 2. Okay, step 2, see if it's on the unicircle. Well, we plug it into these formulas. It'll be obvious if it's not a unicircle. Cosine theta is equal to x over r, and sine theta is equal to y over r. X is -6, r is 6 square root of 2. The 6's cancel, and we got -1 over square root of 2. Can't have the square root of 2 downstairs, so I'll multiply top and bottom by the square root of 2. Square root of 2 times -1 gives you a negative square root of 2. And square root of 2 times square root of 2, if the square roots are the same, they cancel each other out, and you got negative square root of 2 over 2. Now for the sine. Same thing. We'll put the y value, which is -6, over r. And you notice it's the same as this one up above it. So this is also going to give us negative square root of 2 over 2. So on our unicircle, we're looking for negative square root of 2 over 2 and negative square root of 2 over 2. That is on our unicircle. It's down in quadrant 3. So it'd be pi, 2 pi, 3, 4, 5 pi over 4. And our answer would be r, which is 6 square root of 2, and theta, which we just said was 5 pi over 4. Now again, looking at this on the unicircle, we go around looking for negative square root of 2 over 2 and negative square root of 2 over 2, which is right here, which is 5 pi over 4. Let's look at our next problem. I think this one's on the unicircle also. So we have 3, -3, square root of 3. Same instructions? Yeah, same instructions. So this is x and this is y. First thing, we got to find r. R is equal to square root of x squared plus y squared. Well, x is 3, so we got 3 squared plus y, which is -3 square root of 3 squared. Now 3 squared is 9. Now when you got multiple items inside of parentheses separated by multiplication and division, and you raise it into a power, you can take everything to that power. So we'll take negative 3 squared and the square root of 3 squared. Well, negative 3 squared is 9 times square root and the second power cancel each other out and gives you 3. So I got 9 and 9 plus 9 times 3 is 27. Which gives us 36. And 6 times 6 gives you 36, so r is equal to 6. Okay, let's see if it's on a unit circle. We've got cosine theta is equal to x over r, and sine theta is equal to y over r. Well, x was 3, and r is 6. Now that doesn't look like it's something on unit circle, but if I reduce it, 3 6 reduces to 1/2. Well, yeah, 1/2 is on our unit circle. Now the y. Y is negative 3 square root of 3 over r, which is 6. At this point, it doesn't look like a unit circle, but if I simplify it, 3 and 6 both divisible by 3, I get negative square root of 3 over 2. And that does look like on a unit circle. So we're going to have 1/2 and negative square root of 3 over 2. Let's see. This is x. That's 1/2. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. One half and negative square root of 3 over 2 is 5 pi over 3. So our answer will be r, which is 6, and then 5 pi over 3. Let me save this. And we'll look at the next problem. This doesn't look very promising for the being on a unit circle. And we'll see it isn't. Let's take a look at this. Got negative 0.2 and negative 3.4. Now we find the r the same way. This is x and this is y. So r is going to equal the square root of negative 0.2 squared plus negative 3.4 squared. And let's see what that gives us. We'll do second x squared for the square root. And maybe I ought to do this in 2 different pieces. Let me do it in 2 different pieces. Sometimes students have a hard time with parentheses on these. So negative 0.2 squared. So beginning parentheses, negative 0.2, closing parentheses squared, enter. And we get 0.04. And then we'll do negative 3.4 squared. Put parentheses around it, then squared. And we get 11.56. Let's plug this in our calculator now. So I'll do second x squared 0.04 plus 11.56. And we get this. Now I'm going to take it to 2 decimal places maybe, 3.41. Actually, let me write all the decimal places first. Okay, 3.4058772723. Then r is going to equal to 3.41. That's the first thing we needed. We needed theta now. Now that r is an approximation. I do not want to use 3.41 in my calculations. Actually, using all of this would be an approximation too, which isn't necessarily a good thing. It doesn't matter really for this problem, but if I were to use it for the problem, I'd want to store that. So I'd want to press my store button and then store it in some variable. Let me just show it just to demonstrate it, even though we're not going to use it. So I'll press store, and R is the logical place to store it. Not that I can see that good to see R. There it is, above the times. So do alpha, then the times, and that puts R in there, and we press enter. So then that's there stored, so we can use it from now on. The reason why I say that it's not going to benefit us any is if I go to step 2 and I do cosine theta is equal to x over r. Well, x is negative 0.2, and r is, I'll just write down 3.41. That's not going to give us anything on unit circle. I don't even need to try it, so it fails. So our third step says if it's not on unicircle, then we're going to use tangent theta is equal to y over x. This is why r doesn't matter from the fact that we rounded it, is because I'm not using it in this calculation anyway. Now you can take arctangent on both sides, inverse tangent on both sides, and this is also theta is equal to inverse tangent of y over x. Now I'm going to plug these in. And y is negative 3.4, and x is negative 0.2. Let's see what this gives us. So second tangent, negative 3.4 divided by negative 0.2. Close parentheses and enter. And we're in degrees. What do they probably want? The ones up above this have been mostly in radians. I think there was one that was in degrees, but mostly in radians. So let's actually switch our calculator to radians and do it again. Okay, so I'm going to press my mode. I'm going to down arrow to the line that says radians and degrees and press enter on radians. Exit out, do a second mode, and I'm going to do a second enter to bring up the previous entry. Okay, and we get this. Now if I was going to use this in further calculations, then I'd want all the decimal places, but I'm not. So I'm going to go ahead and round it to 1.51, like this. Now we have a note. When using tangent theta is equal to y over x formula, check your quadrants. So check your quadrants. Now remember, where inverse tangent is valid, it's valid from negative pi over 2 to pi over 2. So inverse tangent is valid here and here. So it won't even give you answers that are over in quadrant 2 and quadrant 3. That's why you have to check your quadrants. Okay, let's look at our original problem. Negative 0.2, negative 3.4. Let's see where that point is. X is negative, y is negative. It's over here somewhere. I don't care exactly, but it's over here. Let's see what we came up with. Now r doesn't matter, but we came up with theta is equal to 1.51. 1.51 in terms of radians, this is pi over here, so this is like 3. And 1.51, boy, I'm going to have to quit being sloppy here, I guess. That's so close to that. Here's 3.14. And this is pi over 2, so let's see what that is in our calculator. Second caret divided by 2. This is 1.57. Now look what we came up with. We came up with 1.51. So what we came up with is over here. Well, that's not where we wanted. This is what we came up with. We wanted it down in this quadrant. Well, if you look at it, if we add pi to that, that'll give us it in that quadrant. So theta is equal to 1.51 plus pi. So let's see what we get. We already have that in our calculator. No, we don't. I lied to you. It's right up here. But anyway, and actually maybe I should use the original value. If I do second inner, it'll bring up previous entry. If I do second inner, it brings up the next one, which is that right there. So this is what we have, 1.51. And I said I'm going to add pi. So I do plus second caret for pi, inner. And we get 4.65. Now 4.65 is in the appropriate quadrant. So our answer is R, which is 3.41, and theta, which is 4.65, and that's in radians. Now let me recap that, because students have a little bit of trouble with that. We plotted these points, got negative, x was negative, y was negative. So I knew it was down in this quadrant. Doesn't matter where, I'm just looking at the quadrant. What I came up with was theta is equal to 1.51, which is over in this quadrant. And that's not the quadrant I wanted to be in. So to get to this other quadrant, I just added pi to it. And that got me over there. Let's look at another problem. This is another one of those. Obviously, it's not on unicircle. Negative 1.9 and 0.15. Okay, first thing we do is find r. R is equal to square root of x squared plus y squared. So we're going to have negative 1.9 squared plus 0.15 squared. Now if you're careful on plugging these in the calculator, you can do it all at once. If I come over here, I'll do the square root. And I had to put parentheses around the negative 1/9. So beginning parentheses, negative 1.9 in parentheses squared. Plus, I don't need parentheses around the other part. There's no negative there. Doesn't hurt to put it there though. If I put begin parentheses, 0.15, close parentheses, squared, and enter. You don't need closing parentheses at the very end. I know it's not on unicircle, so I'm not going to worry about putting the exact amount down. I'll take it 2 decimal places. And we got 1.91. Don't even need to try this. I know it's going to fail. Cosine theta is equal to x over r. If I put this over that, that's not going to give me something on unicircle. Maybe close. So I'll go to step 3. Theta is going to equal to inverse tangent of y over x, which will give us our angle, but sometimes it won't be in the right quadrant. Now, if the problem's wanting this in degrees, you just need to make sure you go to mode and you change it to degrees. I couldn't tell you what the particular instructions are looking for in your textbook. Y is 0.15, x is negative 1.9. So let's see what that gives us. So I do second. What am I in? I'm in radians. Okay. And then second tangent is 0.15 divided by negative 1.9. Enter. And we get negative 0.08. Actually, let me put all the decimal places. 0.07, 87, 83, 9, 61. Now, let's look at what we got here. For our point, it's negative 1.9, x is negative, y is positive. So we're over here somewhere. Let's see what we came up with. Negative 0.07. Well, if this is 0, down to here would be negative 1.57 if I was going in this direction. So negative 0.07 is somewhere over here. Don't know where. But obviously it's in the wrong quadrant, isn't it? So what I want to do is I need to get over to the correct quadrant. So I'm going to add pi. So adding pi will get it over to our correct quadrant. So theta is going to equal to that right there. And I'm going to add pi. Well, this is already in our calculator, so I just do a plus, second caret for the pi, enter. And I'll take it 2 decimal places, so we get 3.06. So r is 1.91, and theta is 3.06. Now, if I look at it, 3.06 and 1.91, that makes sense for what quadrant it's in. So you have to be careful. Now, you don't always have to add pi. You have to look at each individual problem. It could be that it gives you the correct angle. You just have to look at it and see. And did that take okay? Let me save it again, just in case. Software's kind of flaky. 1239. Yeah, it looks like it went okay. I hate how it flips me out of it and throws me some other kind of oddball package. Now the next ones want us to, we're given equations, and we're wanting to switch them over to the other type. This is rectangular, of course. We have x's and y's, and they want us to put it into r and theta. Well, let me write down our formulas. X is equal to r cosine theta. Y is equal to r sine theta. We got tangent theta is equal to y over x. We got cosine theta is equal to x over r. Sine theta is equal to y over r. We got r squared is equal to x squared plus y squared. We got r is equal to square root of x squared plus y squared. So that's what we have to work with. Let me take a drink. And let's look at this problem. We got x squared plus y squared is equal to 2x minus 3y. It says the letters x and y represent rectangular. Write each equation using polar coordinates. Well, this one's pretty straightforward. You see that over here we got x squared plus y squared is equal to r squared. So this right here just becomes r squared. Now over on this side we got x, but we said x is equal to r cosine theta. So we replace the x with r cosine theta. Minus 3, and y we said was r sine theta. Now they don't give us any kind of particular instructions like simplifying it or anything like that. So that's our answer. Now we could divide everything by r and put it in a different form. Because yeah, this is an r, this has an r, and this has an r. And we're running an assumption you can't have r is equal to 0 with this equation. That would give us r is equal to 2 cosine theta minus 3 sine theta. But again, they don't give any kind of specific instructions like simplified or write in any kind of form, so it's hard to say what they might do. Might be this, and might be this. Let's take a look at this one. We got 5x y squared is equal to 3. And again, we want to switch it over to polar. Well, easy enough. X we said was r cosine theta. So put that in there for x. Y we said was r sine theta. So put that in for y. Equals 3. Technically, that's our answer. Because they didn't say anything about simplified form. I could simplify it further. When you square this, if everything inside your parentheses is multiplication or division, you square everything inside. So we square the r, which would give us r squared, and we square the sine, which would give us sine squared. Well, we got 5. R times r squared is r to the third. Cosine theta sine squared equals 3. Again, I could go a lot of different paths on this. You know, we could replace sine squared with 1 minus cosine squared and put everything in terms of cosine. I could divide both sides by 5 to get the number over here. I could take that number over. They don't really specify, so your guess is as good as mine. Now later on we will write it into a specific form, but for now they don't care, or don't appear to care. R is equal to cosine theta minus 2. And instructions are, the letters R and theta represent polar coordinates. Write each equation using rectangular coordinates, x and y. Well, if we look up here, we got r cosine theta is equal to x. That doesn't fit because we don't got an r in front of it. I could use this one. Cosine theta is equal to x over r. And that would work. We have to do a little bit of twisting on it to get it to work. But what we can do is, to begin with, we go ahead and multiply everything by r. So r times r times cosine theta, and r times negative 2. Which would give us r squared is equal to r cosine theta minus 2r. Now r squared is right up here. It's x squared plus y squared. R cosine is x. Minus 2r, and r we said was the square root of x squared plus y squared. And again, it doesn't specify any particular form, so that would be our answer. Let's look at our next example. R is equal to 7. Easy one. R is right up here. We said it's square root of x squared plus y squared. So, square root of x squared plus y squared. And this is our answer. Now again, they could simplify it further. We could square both sides, and then we'd have x squared plus y squared is equal to 49, which is a circle, which is what r is equal to 7 is. So hard to say where they'll go with that. This technically is done per the instructions. This one's a little bit tricky. Theta is equal to pi over 4. If I come up here, I don't have any formula just for theta. But I do have tangent theta, so let's work with that. What I can do is down here I can go ahead and take tangent of both sides. So we got tangent theta is equal to tangent of pi over 4. Now over on the left side, tangent theta is from our formula y over x. This one right here. So I can replace that with y over x. Now I can look this up on my unit circle. Tangent of pi over 4. Tangent on our unit circle is y over x. And by pi over 4, we got square root of 2 over 2 and square root of 2 over 2. Which gives us 1. Here's pi over 4, y over x. Square root of 2 over 2 over square root of 2 over 2 would give us 1. Technically, this is our answer. I'm guessing they'll probably multiply both sides by x at least, though. If you multiply this side by x and this side by x, you get y is equal to x. But again, hard to say where they'll go with that. And our last problem. r is equal to 5 over 5 plus sine theta. Well, I can get rid of the fraction by multiplying both sides by 5 plus sine theta. So r times 5 plus sine theta equals 5 plus sine theta times 5 over 5 plus sine theta. This 5 plus sine theta cancels that 5 plus sine theta. And over here we got r times 5, which is 5r, and r times sine theta, which is r sine theta. Why did I do this? Well, we don't have, if we look up here, we don't have many fractions in terms that would help us. We have a fraction here, but that wouldn't benefit us. So it's just logical to get rid of that, unless we have y over x, and going to theta. Well, now r is equal to the square root of x squared plus y squared. R sine theta, that's y, equals 5. And again, I'm not going to spend any kind of time rewriting it in any kind of form because they don't specify. So that'd be our answer. And that's the last one there, so let me save this page. And stop the recordings.